According to the National Electrical Code, Article 337, which pertains to underground feeder and branch circuit cable, installing Type W cable in rigid non-metallic conduit, that is PVC, is permissible, but with specific considerations. Firstly, the run length from the bulkhead to the panel should be between 20 feet and 50 feet. Secondly, the PVC conduit must be of an adequate size to accommodate the Type W cable along with any other conductors that might be present. Thirdly, the conduit needs to be securely fastened to both the bulkhead and the panel, ensuring it is protected from any form of physical damage. Fourthly, the Type W cable must be properly terminated at both ends, using connectors that have been approved for this purpose. Additional considerations are necessary. Firstly, the PVC conduit needs to be buried at a minimum depth of 18 inches below the finished grade. However, there is an exception if the conduit is protected by another approved method, such as encasing it in concrete. Secondly, proper grounding of both the PVC conduit and the Type W cable is essential, and this must be done in accordance with the requirements outlined in the National Electrical Code. Thirdly, it is imperative to ensure that the Type W cable is rated appropriately for the temperature conditions that are present in the installation location. Fourthly, if the installation is located in an area where corrosion is a concern, additional protection measures may be necessary for the PVC conduit to prevent degradation over time. In conclusion, running Type W cable and PVC conduit from a bulkhead to a panel is permissible if it falls within the distance specified and if all of the applicable requirements of the National Electrical Code are adhered to. It is critical to pay close attention to the size of the conduit, the installation methods used, the proper termination of the cable, grounding procedures, temperature ratings, and protection against corrosion. This will ensure a safe and compliant electrical installation. When selecting the appropriate size of PVC conduit for Type W cable, several factors must be considered to ensure compliance with the National Electrical Code and to provide adequate protection for the cable. Firstly, the conduit must have sufficient in a diameter to accommodate the Type W cable, plus any other conductors that may be installed within the same conduit. Secondly, the conduit must be large enough to allow for easy pulling of the cable during installation, without causing damage to the cable insulation. Thirdly, the conduit fill requirements specified in the NEC must be followed to prevent overheating and to ensure proper ventilation. To determine the appropriate conduit size, you will typically refer to NEC Chapter 9, which provides tables and guidelines for conduit fill calculations. These tables specify the maximum allowable percentage of conduit cross-sectional area that can be occupied by conductors. You will need to know the outer diameter of the Type W cable and any other conductors to accurately calculate the conduit fill. The NEC provides tables that list the dimensions of various types of conductors and cables. Once you have determined the total cross-sectional area of all conductors, you can use the NEC tables to select a conduit size that meets the fill requirements. For example, Table 1 in Chapter 9 provides the percentage of conduit area that can be occupied by different numbers of conductors. It is essential to select a conduit size that provides sufficient space for future expansion or the addition of conductors. It is always a good practice to choose a slightly larger conduit size than the minimum required to allow for flexibility. In addition to conduit fill requirements, the NEC also specifies minimum bending radii for conduits to prevent damage to conductors during installation. Ensure that the selected conduit size allows for bends that meet these requirements. Different types of PVC conduit have different dimensions and properties. Schedule 40 PVC conduit is commonly used for underground installations and provides good physical protection. Schedule 80 PVC conduit has thicker walls and is suitable for applications where greater mechanical strength is required. Ensure that the selected conduit type is appropriate for the installation environment and complies with local codes and regulations. Local electrical inspectors have the final say on whether an installation meets code requirements. It is always a good idea to consult with the local inspector or a qualified electrician to ensure that the selected conduit size and installation methods are compliant. The grounding of PVC conduit and Type W cable is a critical aspect of electrical safety and must be performed in accordance with the National Electrical Code. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and to energize the circuit in the event of a ground fault. While PVC conduit itself is non-conductive and does not require grounding, a tight W cable installed within the conduit must be properly grounded. The grounding conductor within the type W cable provides the necessary ground fault path. The grounding conductor in the type W cable must be connected to the grounding electrode system at the service equipment or separately derived system. This connection ensures that the entire electrical system is properly grounded. Typically, a grounding electrode conductor is run from the service equipment to a grounding electrode, such as a ground rod, ground plate, or metal water pipe. The grounding conductor from the type W cable is then connected to this grounding electrode conductor. The size of the grounding conductor must be determined based on the size of the ungrounded conductors in the circuit as specified in NEC Table 250.122. The grounding conductor must be large enough to safely carry the maximum ground fault current. All grounding connections must be made using approved connectors and methods. Ensure that the connections are clean, tight, and corrosion resistant. Avoid using methods that can loosen or corrode over time. If the PVC conduit run is long or if there are multiple sections of conduit, it may be necessary to install supplemental grounding electrodes along the run. This helps to ensure that the grounding path remains effective even if there is a break in the main grounding conductor. In some cases, it may be necessary to bond metallic enclosures or equipment to the grounding system. This helps to prevent voltage differences between different metal parts, which can be a shock hazard. The specific bonding requirements will depend on the type of equipment and the installation environment. Local electrical codes and regulations may have additional grounding requirements that must be followed. Always consult with the local electrical inspector or a qualified electrician to ensure that the grounding system is compliant. Proper grounding is essential for electrical safety and helps to protect people and property from electrical shock and fire hazards. Ensure that the grounding system is properly designed, installed, and maintained. The appropriate burial depth for PVC conduit containing type W cable is a critical factor in protecting the cable and ensuring the longevity of the installation. The National Electrical Code specifies minimum burial depths for underground wiring based on the voltage of the circuit and the type of wiring method. For residential branch circuits and feeders operating at 120 volts or 240 volts, the minimum burial depth for PVC conduit is typically 18 inches below finished grade. This depth provides adequate protection from physical damage caused by digging, landscaping, or other activities. If the PVC conduit is installed under a driveway or parking area, the minimum burial depth may need to be increased to 24 inches or more, depending on the local codes and the expected traffic load. In areas where there is a risk of frost heave, the conduit should be buried below the frost line to prevent damage from the expansion and contraction of the soil. The depth of the frost line varies depending on the geographic location and the soil conditions. In some cases, it may be permissible to reduce the burial depth if the conduit is protected by a layer of concrete or another approved method. The concrete provides additional physical protection and helps to distribute the load over a wider area. The trench of the PVC conduit should be wide enough to allow for proper installation and backfilling. The bottom of the trench should be smooth and free of rocks or sharp objects that could damage the conduit. The conduit should be laid on a bed of sand or compacted soil to provide stable base. After the conduit has been installed, the trench should be backfilled with soil that is free of rocks and debris. The soil should be compacted in layers to prevent settling and to provide support for the conduit. Warning tape or other markers should be placed above the conduit to alert anyone digging in the area to the presence of underground wiring. The warning tape should be buried at a depth of about 12 inches below finished grade. Always consult with the local electrical inspector or a qualified electrician to determine the appropriate burial depth for PVC conduit in your area. Local codes and regulations may have additional requirements that must be followed. Proper burial depth is essential for protecting underground wiring and ensuring the safety and reliability of the electrical system. When selecting type W cable for use in underground PVC conduit, It is essential to consider the temperature rating of the cable to ensure that it is suitable for the environmental conditions in the installation location. The temperature rating of a cable indicates the maximum temperature that the cable insulation can withstand without degrading or becoming damaged. Type W cable is typically rated for wet or dry locations and for a maximum operating temperature of 90 degrees Celsius, which is 194 degrees Fahrenheit. However, the actual temperature rating may vary depending on the specific cable manufacturer and the cable construction. The ambient temperature of the installation location is a critical factor in determining the appropriate temperature rating for the cable. In underground installations, the ambient temperature can be affected by factors such as soil temperature, depth of burial, and proximity to heat sources. The NEC requires that conductors be selected and installed in accordance with their temperature ratings. The ampacity of a conductor, which is the maximum current it can carry safely, is affected by the ambient temperature. The NEC provides tables that list the ampacity of conductors at different temperatures. If the ambient temperature is higher than the temperature for which the ampacity is listed, the ampacity must be derated to prevent overheating. The terminations and connectors used with Type W cable must also be rated for the appropriate temperature. Ensure that the terminations and connectors are compatible with the cable and that they are suitable for the environmental conditions in the installation location. In some cases, it may be necessary to use a cable with a high temperature rating to ensure that it can withstand the expected ambient temperatures. For example, if the cable is installed in a location where it is exposed to direct sunlight or heat from other equipment, a higher temperature rating may be required. Always consult with the cable manufacturer or a qualified electrician to determine the appropriate temperature rating for Type W cable in your specific application. Proper temperature rating is essential for ensuring the safety and reliability of the electrical system. In areas where corrosion is a concern, providing additional protection for PVC conduit containing Type W cable is crucial to prevent premature failure of the system. Corrosion can be caused by a variety of factors, including exposure to moisture, chemicals, and salt. The type of soil in the installation location can also affect the rate of corrosion. Certain types of soil, such as those with high clay content or those that are acidic, can be more corrosive than others. If the installation is located in an area where corrosion is a concern, consider using corrosion-resistant PVC conduit. This type of conduit is made from a special PVC compound that is designed to resist corrosion from chemicals and salt. There are several types of corrosion-resistant coatings that can be applied to PVC conduit to provide additional protection. These coatings can help to prevent corrosion from moisture, chemicals, and salt. When installing PVC conduit in a corrosive environment, use corrosion-resistant fittings and connectors. These fittings and connectors are made from materials that are designed to resist corrosion. Backfilling the trench with a non-corrosive material can help to protect the PVC conduit from corrosion. Sand or gravel are good choices for backfilling materials because they are non-corrosive and provide good drainage. Installing a cathodic protection system can help to prevent corrosion of underground metallic structures such as metallic conduits and grounding electrodes. Cathodic protection systems work by applying a small electrical current to the structure, which helps to prevent corrosion. Regular inspections of the PVC conduit and Type W cable can help to identify potential corrosion problems early on. If corrosion is detected, take corrective action to prevent further damage. Always consult with a qualified electrician or corrosion specialist to determine the best methods for protecting PVC conduit and Type W cable in your specific application. Proper corrosion protection is essential for ensuring the long-term reliability of the electrical system. The National Electrical Code, or NEC, serves as the cornerstone for safe electrical installations in the United States. It is a comprehensive set of standards and guidelines designed to protect people and property from electrical hazards. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is published by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for the design, installation, and maintenance of electrical systems. The NEC is organized into chapters, articles, and sections, each covering a specific aspect of electrical safety. It includes tables, diagrams, and examples to help clarify the requirements. Local jurisdictions may adopt the NEC with or without amendments. It is essential to check with a local electrical inspector to determine which version of the NEC is in effect and whether there are any local amendments. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations are compliant. They review plans, conduct inspections, and issue permits. Failure to comply with the NEC can result in fines, project delays, and safety hazards. The NEC is not a design manual, but it provides the minimum requirements for safe electrical installations. It is the responsibility of qualified electrical professionals to design and install electrical systems that meet or exceed the NEC requirements. Continuing education is essential for electrical professionals to stay up to date on the latest changes to the NEC and to maintain their knowledge of safe electrical practices. The NEC is a living document that is constantly evolving to address new challenges and technologies. By staying informed and adhering to the NEC requirements, electrical professionals can help to ensure the safety of people and property. A qualified electrician possesses the knowledge, skills, and experience necessary to safely and effectively design, install, and maintain electrical systems. Hiring a qualified electrician is essential for ensuring the safety and reliability of electrical work. Qualified electricians have completed extensive training and apprenticeship programs. They have a thorough understanding of electrical theory, wiring methods, and safety codes. Electricians must be licensed by the state or local jurisdiction in which they work. Licensing ensures that electricians have met certain minimum standards of competency and that they are subject to regulatory oversight. Qualified electricians have experience working on a variety of electrical projects. They are familiar with the challenges and complexities of different types of installations. Electricians are trained to identify potential hazards and to take appropriate safety precautions. They use specialized tools and equipment to safely work with electricity. Electricians are knowledgeable about the National Electrical Code and other applicable codes and regulations. They ensure that electrical installations comply with all relevant requirements. Electricians can provide valuable advice on the design and planning of electrical systems. They can help to select the right materials and equipment for the job. Electricians can troubleshoot electrical problems and make repairs quickly and efficiently. They have the knowledge and experience to diagnose and fix a wide range of electrical issues. Hiring a qualified electrician can save time and money in the long run. They can prevent costly mistakes and ensure that the electrical work is done right the first time. Electrical work can be dangerous, and it is always best to leave it to the professionals. Hiring a qualified electrician can protect you, your family, and your property from electrical hazards. When hiring an electrician, ask for proof of licensure and insurance. Check references and read online reviews to get an idea of the electrician's reputation. Get a written estimate before the work begins, and make sure that the estimate includes all costs, including labor, materials, and permits. Always use a qualified electrician for any electrical work, no matter how small or simple it may seem.